Oh, what's up, AP Calculus students? Mr. Ford here with another homework tutorial. This is our first homework for Chapter 4.1.1, which is the first section of Chapter 4, and we've kind of got a couple new ideas that we'll really be looking at in Problem 4.7, but for the rest it is very much review, so let's go for it. In 4-6, while driving to work, Mr. Matluck's velocity is given by v of t equals 15t plus 10. That is a velocity function where t is in hours and v of t is in miles per hour. Determine how far Mr. Matluck lives from school if it takes him. Okay, cool. So, how far is a distance thing? So in order to go from, here's the thing we'll talk about in class today, but in order to go from velocity to distance, we are looking at the area under the curve. And what's nice about this is that our curve is not a curve at all. It's a nice straight line, which means we're going to be able to use some basic geometry to answer these questions. So as far as the 1 hour to get to work question goes in part A, that's going to be a trapezoid. And the area of that trapezoid is going to be 1/2 times the bases added together, which looks like 10 plus, man, I'm guessing that's 20? Wow. Oh, we do have the function, don't we? Let's see, v of 1 would be 25. So, be 10 plus 25 times 1 for the base there. So that would be half of 35, which is, on my calculator really quick, 35 divided by 2 is going to be 17.5 miles. Getting my answer kind of mixed up with my miles per hour right there. 4 hours to get to work will be kind of the same game. Now we'd be looking at this green trapezoid, but pretty much everything is going to be the same. In fact, the only thing that's going to change is the second number. We got it last time by plugging in 1 into the function. This time we're going to have to plug in 4 to that function. 15 times 4 is 60. 60 plus 10 is 70 times, and this time times 4. So a couple extra things. Now 4 divided by 2, right in front, we're going to have those numbers. They're going to cancel out to make 2. So basically this is going to boil down to 2 times 80, which is 160 miles from work. That's a long time for somebody to be driving. For a half hour from work, it would be this tiny trapezoid, much more reasonable for somebody's commute. In this case, the area would be 1/2 times 10 plus, let's see, 15 divided by 2 is 7.5. This would be 17.5. Right there again, and plugging in 7.5 into the function, or sorry, plugging in 0.5 into the function. 15 times 0.5 will give you the 7.5, plus 10 is 17.5, times 1/2. This one might actually be a little more rough to work with. It's going to be 27.5 divided by 4 when we're all done. And that's not going to be a nice number. It's 6.875 miles, of course, is the thing there. And t hours to get to work. Well, if you followed along with the pattern so far, what we're doing is just taking this number and plugging it in to this function up there. So what's going on here, you're going to have the area is always going to be 1/2 times 10 plus v of t, really, is what's going on there. We're just plugging in that number in, v of t times t. For the height. You see that pattern exhibited throughout this 1 times 1, 4 times 4, 1/2 times 1/2. And what we have here is we have v of 1, let me use blue, v of 1, v of 4, and v of 1/2 right there. So we're just kind of taking the different parts and putting them into the thing. I don't think we need to go any further with that or simplify it because we really can't. So I suppose you could replace v of t with 15t plus 10 and then work it out. In fact, that might be worth just looking at really quick. It's probably not that hard to do. 10 plus 15t plus 10 times t. Let me see if this works out to be anything reasonably nice. We'd have 20 plus 15t times t. So it's all going to come down to, this is 10 plus 15 over 2t. Times t. So it comes down to 10t plus 15 over 2t squared. That's another way to think about it. It's a little more advanced of an answer, but that works too. Okay, let's move on to the next question. Here's kind of the summary of what we're going to do in class today. By the way, this function is even. That's the first question, and that's pretty easy to get because this graph here is symmetric to the y-axis. So you can flip it over the y-axis and get the same thing. That's actually going to allow us to answer all of the other questions. What we're told is that the integral from 0 to 2 of f of x dx is equal to 10. The translation of that for us right now is that the area of this little chunk under the curve, that's equal to 10. Right there. So the question we're asked is, what's the integral from -2 to 2 of f of x dx? And that would be the area under the curve from -2 to +2, which would include this little chunk right next to that. Now, fortunately, since this is an even function, we know that if this chunk is 10, this chunk is also 10. So the total area under the curve there would be 20 for the answer there. The explanation is that it's symmetric. So if you really wanted to get fancy with the explanation there and use some good symbols, I know the integral from -2 to 0 of f of x dx equals the integral from 0 to 2 of f of x dx. And I'm really going to push early on in this section to practice that notation, because the sooner you can get used to it, the easier your time will be for the remaining chapters of this class. Question C is going to be very similar, I think. If the integral from 0 to 3 is -2 and the integral from 0 to 2 is 10, what's the value of the integral from 2 to 3 of f of x dx? We actually don't need the graph at all to answer this question, because here's kind of a mathematical equation I'm going to write off to the side, is that the integral from 0 to 3 of f of x dx is equal to the integral from 0 to 2 of f of x dx plus the integral from 2 to 3 of f of x dx. Basically, breaking up the chunk from 0 to 3 into two small chunks, one from 0 to 2 and then another one from 2 to 3. So if they tell us that this is, let's see, 0 to 3 is -2, I think is what they told us. Yeah. And 0 to 2 is 10. You can kind of just think about this. Let's treat this like x. We don't know that like that. That's basically what we're solving. That means it's got to be -12. -12 has to be the integral from 2 to 3 of f of x dx, because 10 plus -12 will give you the -2. Question D, if you know the values of the integral from 0 to 3 and the integral from -2 to 2, how can you determine the value of 2 to 3? Justify your process with a diagram if necessary. Let's see. Well, we kind of just did it in the previous problem. I think the missing part in the problem D is that we would first need, in order to take the integral from 0 to 3 and find the integral from 3 to 2, we have to know the integral from 0 to 2. That's kind of a thing. We need to know the integral from 0 to 2 of f of x dx. But we can find that because we know this is an even function from the top of the problem. So we know these two chunks there have to be equal to each other. So what we can do to find this, we can take the integral from -2 to 2 of f of x dx. We can divide it by 2. And once I know that number, I can subtract that from the integral from 0 to 3 and figure out what the integral from 2 to 3 is. That's kind of the process there. So I think if I had to outline this a little bit more clearly, maybe walk through it one more time. Step 1, I would do integral from -2 to 2 of f of x dx and divide it by 2, and that equals the integral from 0 to 2 of f of x dx. The next thing I would do is take the integral from 0 to 3 of f of x dx and subtract the integral from 0 to 2 of f of x dx, and that will tell us the integral from 2 to 3. That's kind of the process of this problem. Again, the sooner you can get used to the notation, the easier time you'll have going forward with this. Okay, let's do some more review questions. 4.8, for each function, we're going to write the slope function. We're going to find the derivative. So let's get into it. We're just going to use the power rule here a bunch of times, f prime of x in this first problem. Let's see, -2 times 2/5 is going to be -4/5, x to the -3rd power, minus 4. And you could simplify that further if you wanted to, but I'm kind of beyond that at this point. Let's just leave it. Question B, I think it's a good idea for you to just kind of memorize that this is the square root of x, which equals x to the 1/2 power. It's a pretty common derivative, so you'll see it enough times that you'll probably memorize it anyway. F prime here is going to be negative 2 over, let's see if I think about this, F prime. Well, we're going to have negative, let me think about this differently. Negative 2 times, we'd have the 1/2 down in front times x to the negative 1/2 power, and what that would give us would be negative 2 on top, 2 on bottom, and the square root of x on the bottom also. And those 2's would balance out, it'd be negative 1 over the square root of x. For question C, the derivative of cosine is negative sine, so f prime in this problem would be negative 6 sine of x. And in question D, that looks like we might not be able to do it right now, but we actually can, because you can easily factor out, on the top, you can factor a 4 out and get x squared plus 1 over x squared plus 1. And this is just the graph of y equals 4. Those kind of cancel out. It's not the graph of y equals 4. It has a hole. Actually, no, there's no holes on it because it will never actually be 0 on the bottom. It doesn't matter. Since this is a constant number, f of 4, the derivative f prime is going to be 0. Like that. Question 4.9 is probably a good idea for us to just review this process because it's becoming relevant again for us as we start our study of integrals. Write a Riemann sum that approximates the area under the curve from, is that supposed to be? Now, hang on, I'm going to check on a different monitor. I'm going to check to see if I can get the a better artist's rendering of this problem. That's supposed to be negative 8 to 8? It is negative 8 to 8. It did not copy very well on this paper, which is kind of weird that these black line masters that I'm using don't have a good copy. Okay, anyway, this is negative 8 to 8. Using the given number of rectangles, if f of x is something. Okay, so let's just break this down for question A. Well, first thing we got to do is kind of a b minus a over n. We kind of need that calculation for a lot of things. In this problem, that's going to be 8 minus negative 8 over, I guess in problem A, it's 16. So that's actually nice because that's 16 over 16, which is just 1. So this would be sigma from I equals 1 to 15, n minus 1. You would have 1 times f of, your a, in this case, is negative 8, plus, usually it's delta x times I. In this case, our delta x is just 1, so it would be I, and that's it. That actually will do the trick. I think it's a good idea, since our f of x in this problem is equal to 2x to the 1/3 plus 1. Let's go ahead and plug this expression in to x, and we'll have a something we can plug in our calculator. We'll have the sigma from I equals 1 to 15 of, actually, honestly, this just works out because 1 times doesn't do anything. So this would just be 2 times, in parentheses, negative 8 plus I to the 1/3 power plus 1. Honestly, this is simple enough that we can just type this right on the main entry line of our calculator. We don't even have to use the y equals like we usually do. So let's just type this in. I'm just going to clear the home screen. Second, F2, grab your summation notation. Remember, our calculator has to use x instead of I, but x equals 1 to 15. And in this case, we can just go 2, open parentheses, negative 8 plus x, close parentheses, caret key, 1 over 3, plus 1. And we will just execute. And our answer looks like 1. Comes out to be pretty nice, easy to calculate, equals 1 on our calculator. Let's try B, which I suspect will also be rather nice. B is going to ask us to use 64 rectangles instead. It's pretty much going to have the same skeleton to it. The only thing that's going to change, you're still going to have 16 for B minus A, but on the bottom you're going to have 64. So our number of rectangles, or the width of each rectangle, is now going to be 1/4, 16 over 64. So our sigma is going to start being built the same way. We're going to start I equals 1 to 63. This time we are going to have a 1/4 in front, times f of negative 8 plus 1/4 I. That's what we're going to do. So this is going to be a little more complicated to type on the calculator, but we'll make it work. It'll be exactly the same kind of expression. We're just going to substitute negative 8 plus 1/4 I in for x up here. So that will be sigma I equals 1 to 63, 1/4 times Let's be really careful. I'm going to make a big old parentheses out in front here. So it's going to be 2, open parentheses, -8 plus 1/4 I, close parentheses, to the 1/3 power plus 1, close big parentheses. Kind of like that. It can get a little hectic, but that's what we're going to type in the calculator. This will give us a better answer than what we got in the first chunk because this is using more rectangles. I'm actually just going to arrow up and grab this same thing so we can do a couple shortcut tricks to make our lives a little easier here. First thing I'm going to do is change 15 up top to the number 63. I'm going to push second delete to open up the insert thing, which changes your cursor to a little dash there. And I'm going to push alpha x to make it a fraction. I'm going to put 1/4 in front there. And then, with my insert still active, I'm going to put another parentheses in front of this thing. So now this is kind of my big idea. So now it's 2 times -8 plus, I got to put another insert here. Insert fraction, 1/4. And then if I count the number of open parentheses I've got so far, I've got open, 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 close, close. I got one more to close out here. I think that should do it. We'll push enter on that one and see if it gives us the right answer we're looking for. Let's get to think about it a little more this time. I thought I might have made a syntax error in there. Did I open up too many parentheses? I didn't need that one, apparently. Oh, okay. Oh, no. Okay, hang on. I got to play with the order here. I need the 1/3 power to be outside here. There we go. And then I need here to be the +1. That's what it's got to be. So I need, if I'm thinking about this correctly, I need the calculator to do -8 plus 1/4 x first, raise that to the 1/3 power, multiply that times 2, and then add 1 to that. And then after it's all done, multiply it by 1/4. I think this will work. Let me go ahead and push enter to see if the calculator gives us that syntax error again. Okay, let's see. Where's the problem now? Let's delete that. Maybe that's the problem. Okay, we'll try running it one more time. Maybe this will be a 1. 63, which that seems to be going from 1 to 63. I mean, I guess I'll write it down. It seems to be excessive to jump from an estimation of 1 to an estimation of 63. Let me just check my objective answer guide here and see if we get agree with the same answer here. Oh, I'm supposed to get 12 for the first one and 15 for the second one. 5 times 2. Oh, I think I'm supposed to have I think I had the I wrong in both those examples. Hold up. I think this is supposed to be a 0 down here. Otherwise, I think I have it set up correctly. Still giving 63, eh? 1/4, -8 plus. Just gonna check, because I don't know. I might be feeling strong enough to say that that's what I think it is. -8 plus I over 4 to the 1/3 power times 2 . What if I go up in here? What if I delete this parenthesis in here? What does that do? Nope, I can't. Could I insert another parenthesis there? Would that help me out? Will that change things? I wonder. Okay, that does change things. I guess I had parentheses in the wrong spot. So this is what you want to actually type in. I guess I had counted the parentheses the incorrect way. 15 is the correct answer here. And if I were to go back and fix the answer for the previous problem, let's see, maybe I can go actually arrow up and find it real quick. It's probably hanging out right here. There we go. Let's take that one. Let me change that to 0 down below. probably important to get the right answer here. What do I want here? So what's going on here? I'm getting, oh, okay, I see. I want the 1/3 power to happen right here after that parentheses. That's different. 1 divided by 3, please. Delete. Perfect. Yeah, because I want the -8 plus x to happen first, then the 1/3 power times 2, then plus 1. This will probably change a little bit. -3. Still not the same answer that the book is getting. Hang on, I'm just going to confirm that I am not insane. -8 plus 1 to the 1/3 power. Maybe I should, let me put one more set of parentheses around this thing, just make sure I got the right operational order here. Oh, go to. Maybe not. Wait a minute. What if I put the plus 1 in here? That might do the trick. There we go. That's what I had to have, right? I had the plus 1 has to be inside this parentheses, 'cause that's part of it. Otherwise, this is going to run the sigma and then add 1 to the answer. That's what's going on there. I need this to be the whole operation that's going into the sigma. This is 12 over here. Okay. Well, hey, it's important to see things struggle happen anyway, but let's keep going. 410. Use the power rule to write the equation for that function, and then write the equation of the line tangent at x equals 3. We like these problems a lot, so let's keep going. These take a lot of practice, but they're kind of the same steps. I'm going to do my work over down here, I suppose. This will be 410. Our original function is f of x equals x plus 4 times x minus 3. We are looking for the line tangent to f at x equals 3. So the first thing we're going to need to do is to rewrite our original function as kind of a quadratic polynomial here. That'll be x squared plus x minus 12. And in my head, I'm kind of just doing 4x minus 3x to get that to happen, if you're not seeing that quite right now. But it's worth being able to do quick calculations in your head right there. Okay, the next thing we're going to do is we're going to take the derivative of this, because we require that to find the slope. F prime of x will be 2x plus 1, which is pretty easy to do. So when it comes to writing the equation of the line, we want the tangent line at x equals 3. So if we think about our equation, that kind of tells us that the a value we're going to use is 3. We need to know what f of a is, and we need to know what f prime of a is in order to build this equation. So f of a will be 3 squared plus 3 minus 12. We're plugging that into the original function, which is actually really convenient for us in this case. I think that's 0. That's 9 plus 3 is 12, and 12 minus 12 is 0. F prime of a is also really easy to get. That's just 2 times 3 plus 1. In this problem, that's 7. So when we go to actually write the equation of our line, we're going to use y minus f of a equals f prime of a times x minus a. Really simple point-slope form equation. So we have y minus 0 equals 7 times x minus 3. This one's pretty easy to write in slope-intercept form, but you don't need to. You can be done. But 7x minus 21 is all you really got to have there. Okay, we're not going to do F11 for this, or I'll do 411 at the end of this video. Not necessary for this homework assignment, but I'm going to skip it for now. And 412 is also a pretty simple one. I'm not going to fully answer the question. All I'm going to do is explain why Chi is incorrect. Chi thinks that the volumes of the flags are rotated, that the volume of A plus the volume of C is equal to the volume of B plus C. Basically, if you were to take this triangle bit here, that's A, and rotate that around the y-axis, and then rotate C, this rectangle-y bit, around the y-axis, then you would get the same volume if you were to put C and B together and rotate that whole thing. All you got to do really here is draw a kind of a picture of what A looks like on its own. which would be kind of like a cone. You'd have this conical shape where it would have a kind of a circular base like this. And you could draw several circle-y kind of cross sections. Let me try that again from the top so a little more clear. You start with your triangle, your right triangle, draw a circular base like this, and then kind of you have a bunch of different circular cross sections you can make kind of like that. Now if you do the same thing with C and B though, I mean it's not even the same. Well, it looks kind of the same, but you have this rectangle-y bit and then you have another right triangle-y bit kind of like that. The rectangle bit makes a cylinder shape, which is fine. But then the volume of the triangle piece is not the same as the volume of A, and that's what's important here, because you have to swing out a lot further. So there's a lot more volume you got to cover to make that happen. So the volume of the orange, I guess basically a good way to say this, the volume of the orange is not equal to the volume of the blue. And it's because now that the right triangle is out here, you have to rotate it a lot more. There's a lot more volume that you have to make in order to make that rotation happen. So it's not going to be the same. You could go through the whole process of calculating the actual volumes, and I think if you do that, you do not get the same thing. You'll get, I started working on this a little bit. You get 16 pi for A. B would be, let's see, area, let's see, pi r squared times H would be pi times 2 squared times the height of 3. But actually, I don't want to bother calculating B right now because B and C together would be easier to do as a cone minus a missing cone, but even then, it's a lot of work. I want you to see right now the orange is not the same as the blue. That's all I want to walk away with this problem with. So if you're my student, that means this is the end of your homework assignment because I'm not going to assign 411, but you could stick around, and I'm going to work on 411 right now. I think it's good practice to get these some more Riemann sums things. So I'm going to work on this problem over here in this space. Write a Riemann sum that gives the approximate area under the curve from 2 to 5 using n rectangles given f of x is 3x plus 5. So kind of the same process as the problem we worked on a little bit before and ran into some problems with, but b minus a over n in this case is going to be 5 minus 2 over n, which is 3 over n. And I don't think they gave us a number of rectangles. I think they wanted to leave us nice and general with this problem. Yes, n rectangles. We are later on going to use at least 4 different values for n, so we'll do that later. Let's see, and the function is just 3x plus 5. That's pretty easy to work with. F of x is equal to 3x plus 5. So if I'm going to start building a sigma, here's how it would look. It would be sigma from I equals 0 to n minus 1, which would, I'm just going to leave that nice and general. It would be 3 over n times, I guess, well, it's f of, left endpoint is 2 plus 3 over n I, like that. That would be the general one. Otherwise, you could make this a little easier to work with by plugging this expression in for x right there. It might look a little hairy to begin with, but it'll be 3 over n times, in big parentheses, 3 times 2 plus 3 over ni plus 5. Kind of like that. That's a nice general one to do. Now, let me just kind of bust out a few approximations here. Let's do 2. Actually, let's pick numbers that'll work nicely. Let's do 3. Let's do 6. Let's do 12. And let's do 24. I'm just going to kind of picking out multiples of 3, and I want to get big kind of quick. So 24 is, I could go bigger than that, but I'm just going to crunch these out on the calculator, and hopefully I do it right this time. I'm going to try to keep this over on one section of my screen while I make calculator cam kind of big. So I want x equals 0 on the bottom of this thing. Let's start with 3, so I'll put 2 up there. Now the expression would be 3 divided, I actually want to type this as close to the general version as possible, so I know 3 over 3 is 1, but I'm going to keep it nice and simple. Times, open parentheses, 3 times, open parentheses, 2 plus fraction 3 over 3 x plus 5, close parentheses. And I think that should do it. I want to take 2 plus 3 over 3 times x, multiply by 3, add 5, and then multiply that times 3 over 3. I think this is correct. I don't want to keep running into the same problem. I think that should work though, so I'm just going to try it. Oh, see, I got to go to here. I got too many parentheses here. No, 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 but you got to definitely be inside there. So I got to insert one over here and then insert one maybe in front of this thing. Is that enough? 1, 2, 3, 4 open, 1, 2, 3, 4 close. What do you mean? I seem to keep running into the same problem here with this calculator. 2 plus x. I guess maybe I have too many right there. Maybe that's what I'm open, 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 close, close, close. Nope. Go to. Too many there. Open, 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 close, close. Why is there? Wow, now there's 5 of them here inside. Go to. No, that's not right because the plus 5 needs to be part of the. There we go. That's what I want. I need the plus 5 to be part inside the parentheses. I think that's the problem I'm running into with this. I think that's going to be correct. Well, we'll see. Who knows? Now, what I should be able to do is take this same one and change this the value of n. If I want to do 6 rectangles, then this number becomes 5. This number becomes 6, and then this number becomes 6 also. 177 over 4, which is approximately equal to... Give me a decimal here. Mode. What if I do 177 divided by 4? 44.25. Okay. And if I wanted to do n equals 12, again, I would just change this number to the number 11. Whoops. 11. I would change this number to the number 12. Change this number to the number 12. And I would hit enter, and I would get that number. 363 divided by 8 is 45.375. And we'll do one more. We'll do 24. This is going to be the number 23 on top. This is 24. This down here is 24, and that should give us a pretty reasonable approximation. 735 divided by 16. 45.9375. It appears that we're approaching a limit. I would guess that limit looks like it's 46. I guess. I'm just going to make the value of n now something very insane for the end of this video, just to make something crazy. Let's call it 10,000. I'll make it 9999 there. And that means the bottom of this fraction, 1, 2, da, da, da. There, and then da, 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 da. Let's just see. The calculator's going to take a minute to think about this. It might even give me an overflow error, but who knows? I'll just express my gratification at the end of this that anybody still watching this is still with me. I made a lot of calculator errors in this video, and that's frustrating, but that is part of the game. If I see my calculator start to smoke a little bit, I'll know there's something wrong with it. Still going. Still thinking. I'm beginning to think that I may have made an error in making this 10,000. It's taking too long. Let's just look at TikTok while we're waiting. Hilarious. This is still going. I'm going to let this video run until this is done calculating. It'll be fun. My third hour will come in and you'll see them and they're hilarious. So, all right. I'll turn this video off when that calculates. This is hilarious. Hey. Oh, it did it. Hey. Hi, Ford. Cool. 46. Well, I guess I was wrong about the limit we're approaching. It might be 46.5. Who knows? Anyway, thanks for watching this video. Thanks for making it to the end. You're awesome.